right, let's do this. Hello, good morning. My name is Rob. I am that developer dad. It is Thursday, October 24th, and so far for the past week and a half, we've been working on documenting ideas and so on and so forth. And yesterday I touched on, or I started digging into what goes into a validation engine. And we talked about how it's just a collection of rules that are applied to a type within the context of an activity. So I think instead of continuing with the documentation stuff, I want to spend today and maybe tomorrow working on the code that goes into this validation engine concept. Excuse me. So let's do this. I am going to, before I forget, share my screen. Here we go. And this is what's on screen right now is a another little side quest that I'm doing where I'm investigating whether I could use Azure Storage tables instead of a SQL database for my for the main application as well as for the backing data for this, because Azure Table Storage is a whole heck of a lot more cost effective. And if it turns out that it can do everything that I need it to and is at least as fast as the SQL server is for these operations that I'm doing, that'll be a big win. So let's open up the Finder. I'm already in the code window. And let's create a new folder. And we will call it validation engine. And this is just going to be a little experiment. Open a new terminal. .NET new solution. Bop. Oh, template solution file. It's called validationengine.solution. Good. Now, let's go back to the Finder. Open in VS Code. Here we are. Close that. And we'll make this full-sized. And I've got my Explorer over here. I got to open validation engine solution. And I don't need to do that, but I do want to. Oh, come on. Not a new file. Wonder if it'll let me do this. Open with, not text edit, Xcode, other. Where's VS Code? Here it is. Open. That was the Finder barking about. Sometimes VS Code gets me annoyed. Here we go. Open editors. I don't care about that. File. Open folder. Come on, you silly goose. Here we go. Open the size. Select for compare. Open timeline. Yeah. I'm not uploading it to Azure Storage. Go away. C# dev kit. Open. Sometimes that gets goofy. Live preview. Yeah. Okay. That's good. Open to the side. Open with. What a pain in the neck. Fine. Terminal. .NET. New. Class lib, I believe it is. It's not what I wanted to do. Not Safari, I want this. This, and this, and this. Let's delete those. Goodbye. Now, new folder. And I'm just going to create this one as TDD framework. And TDD in this case is that developer dad. New folder. Rules. Engine. New folder. Validation. Engine. Another new folder. Test app. Type. Test app. Yeah, types. New folder. Test console. All right. In here we'll go. Come on. ls, here we go, and cd tdd framework. Oh, I didn't spell it right. Okay, .NET new class library. It's just class lib. Good. CD. Rules. Engine. .NET new class library. Come on, Rob, wake up. Here we go. Now, Safari, new window, and I gotta go to my cheat sheets here. .NET CLI cheat sheet. List. Oh, come on. Wakey, wakey, Rob. I'm on like 1 cup of coffee this morning. Yeah, let's go. .NET solution. .sln add ****.cs project. There we go. And open solution. How about that? All right. I want to shrink the folder explorer and open the solution explorer. That's really annoying. New project. And actually, before I proceed with that, pop over here. Already added rules engine, TDD framework. New project, class library. And I'm going to call this one validation engine. Yeah, fine. Yep. Add a new project. Test app types. What are you doing? Class library. Test app types. New project. Test app console. Boy. Test app console. All right. Now, can I set this as startup project? No. But I can debug, start a new instance, and we should get a hello world in a second. And there's hello world right there at the bottom. Can you see it? There it is, right there in the blue text. Hello world. Good. Excuse me. Suppose I should probably create a launch.json file. C#. Version 2.0 configurations. Add a configuration. How about .NET? VS Code extension developer. Launch, execute, launch C# project. C# project name is test app console. And shrink that out so that I can get the whole line context here. Here we go. Okay. .NET request launch. Save that. Try run and debug again. Nope. Workspace folder slash test app console slash save it. Try running it. Okay, good. Close that. Launch profile should be somewhere. Here we go. Good enough. Okay, so inside TDD framework, I need to rename this class to system object. Boom. And we'll open this guy up, public abstract class system object. Right now, we're not going to actually put anything on here because we haven't yet identified any common attributes or behaviors or anything like that. Excuse me. And we're also going to add, no, not dependencies, but a new class. It's going to be system action base. It too will be abstract and public read-only string action identifier. So I'm just going to call it action name. Stop that. This will be protected. String action name. Equals action name. Whoop. And I'm not actually going to do this as a public read-only string. I'm going to do it as a read-only property. Get, but we're going to give it a private initializer. And what using private init means is that we can only set this within the context of a constructor. And we can only set it within the context of the same class's constructor. Stop that. Abstract. Void execute. Yeah, that works. And then finally, we're going to add one more. It's going to be system func base. Do I need to? Let me think. Yeah, I do. It also will be abstract. It's going to have the similar setup to this. Rename. Function name. Rename to function name. There we go. Where U inherits from system object. I'm also going to public abstract class system action base of T inherits system action base. There we go. Terminate that. Public abstract void execute T subject. Now, let's add some comments here. Is a marker class used to specify that an instance of any derived class can be operated upon by a system action or can participate the activities defined by descendants of system action base or system function base. Save. And I actually need to rename this system object base. Rename symbol. There we go. Save all the things. System action base. Good. Yeah. Good. System object base. All right. System func base. And system action base is defines the simplest implementation of a discrete action that does not return a value and has no parameters. I think I might even, no, I'm going to need system action base as visible. Yeah. Add a documentation on this. The type of the parameter that the action uses in its execution. Defines a single discrete action that accepts a single parameter of a predetermined type. Inherits from system action base, where T inherits from system object base. And because I'm a bit of a weirdo, I'll put my class extenders on new lines. And I'll put my constructor chains on new lines. Save. Not in love with this yet. provides a single discrete function that has a with a return type specified as T. Public abstract T execute. Save. All right. Public abstract T execute U subject where U is a system object base. All right. Thinking. Well, if we have to add more stuff to this later, we can. So, public abstract T execute will run some code that returns a value of type T. Cool? Abstract T execute of U, providing U as the subject, where U is a system object base, performs some function on the using the specified type and returns the type defined in the inheriting class. So that's neat. What might this give us? Well, first we gotta go to our rules engine and add a project reference to TDD framework. And we see that. Public abstract class rule base. Inherits system func base that returns a Boolean. All right. And public system func base of T and consequence can we define generic parameters, get set I don't think it's going to let me use this. Yeah. Now, if we go back to our documentation, here we go. So a rule has the type of system object to which it applies, a string value that identifies the property, a Boolean expression that must evaluate to true. So I skipped a step here. Excuse me. So an expression, I don't want to define the rule base yet, but I'll leave this code here. What even? Rename rule base. All right. And I need to add a class expression base because I can't use expression. Rule expression .C#. This UI, man. New file, class, rule expression has a type applies to type, and I don't really love that name, but no, operand. Prop. I'm just going to do this as an object for now, but operator kind. Prop. Object. You. Expected value. And public bool evaluate object test value. And make sure test value is comparable to the operand type. I need to make this generic. Rule expression of T, where T inherits from system object base. Is that right? No, it's not, because we're not going against system object base. Rule expression of T, all right. Public type operand type. The get on this is going to be return type of t. And because there's code, now you know what? I'm even going to go one step further. Type of t. There we go. I like that. Expected value is of type t. Test value. And that should be about it, but we need some constructors. CTOR. Object. Operator. T. Test value. And operator is a keyword, so operator kind. And this works for when we want to compare a value against another value here. So, operator kind equals operator kind, not king, but kind. Expected value, and I mistyped that. I shouldn't have said test value. I should have said expected value. This will be on init. This will be on init. And I need to save. Throw new, not implemented. Right there, just to shut the compiler up. And we also need to add operator kinds. Equals greater than less than greater or equals less or equals and and contains. Operator kinds. Add a new file. And it's going to be a class. It's going to be internal expression operations. And it will be internal static public static bool is equal this t value to test t expected value. What are you complaining about? What's the damn problem? Oh yeah, not all code paths return a value. Whatever. So value to test is null. It bounces over here and returns false. Otherwise, it runs equals, which is a method on the object class as defined by the .NET framework. Pulls in the expected value. Okay. Public static bool is, and where are my operator kinds? I'm going to pop this into a vertical tab group. Split to the right. Off you go. Here we go, and we'll pull you over here. Is greater than T, this T, value to test, T. Expected value I don't like how it doesn't put the wiggly braces. Now, greater than is not a method on object. If value to test equals null, return false. There's no sense comparing. Otherwise, return value to test is greater than expected value. What's this complaining about? Ah, okay. Where T is value type. Okay, we can't use that as a thing. This isn't going to work out for me. That's okay. It really, really hates all that. The non-nullable type. Oh, stop it. And we also can't do greater than for object and object. Okay. That doesn't work for me. And I remember the last time I did this kind of thing, it kind of did me dirty in the same way. Doing this as a collection of extension methods is just not going to work. That's all right. Internal class, expression operations. In fact, I'm just going to delete this class outright. because, yeah, just go ahead and save it, whatever. You're about to go away. Delete. Yes, go away. I'm going to add a folder to rules engine. Expression operators. New file, class, operator base. Abstract. Inherits. System func base of type Boolean. Do we want to go that far? No. Too much indirection. Base. Get rid of this. Base. Operator. Type. Not even going to bother defining a constructor for this. Operator base T. Yeah. Yes. Public. Type. What's a good name for this? Operand type. Type of T. Public bool. Evaluate. No. Is equal. Public. Abstract bool is equal T. are equal. T. Value to test. T. Required value. Public abstract bool I'm going to say is equal, is greater than, change this R to a lowercase, I'm going to call that base value. Public abstract bool is less than T value to test, T base value, public abstract base, no, bool is greater or equal public abstract bool is less or equal, there we go, contains of T accepted values. And I'm going to start implementing these for the different basic types, strings, ints, doubles, dates, stuff like that, in this afternoon's session. And then we're going to start applying them and using this stuff to build different kinds of expressions. And we're going to combine those expressions into rules. So just before, equals, greater than, less than, greater or equals, less or equals, and contains. Is equal, is greater than, is less than, is greater or equal, is less or equal, and contains. Okay. Pretty simple stuff so far. It gets a little goofy with the inheritance chains and everything like that, but that's fine. Yeah. Yep. Okay. So productive session this morning. I think this afternoon I'll just do ints and strings to start with. Yeah, I'm just going to do ints and strings to start with this afternoon, and then I'll try and wrap up a couple of these into something a bit more concrete, a lot less abstract, so that we can see what kinds of things we can do with these structures. Now, eventually, if you look at this rule expression, why am I going to all this work when I could just, write the code to evaluate this equals that, this is greater than the other thing. This is within this range, etc. Well, I can't store compilable code in the database or in a file. What I can do is store the string values of these properties, and then at runtime I could load those collections of rule expressions in from wherever I've stored them and turn them into instances of this rule expression. And then I can combine these rule expressions or wrap them up in actual rules that apply to various things. I don't know that rule base needs to inherit from system function base. I'm gonna rethink that in a little bit. But I'll be able to serialize all of my rules and deserialize them. And if I can serialize them, I can store them. And if I can store them, I can put a UI in front of it, how they're built and combined and stuff later. But the point is, if I once I nail the data model and get everything executing correctly, I can drop this concept into whatever application I need to run Boolean expressions against arbitrary types. Within here, we're just going to do the default .NET primitives, but I could implement a subscription comparer or a person comparer. I mean, obviously, we're not going to be able to say this person is greater than that person or what have you. But we will be able to implement some types of these rules. And we'll be able to combine those rules into different things. And this rule expression, the expected value on this is I'm going to get rid of that. Yeah. We just need the operator kinds. And we're not going to set that expected value at when we instantiate the rule. We are going to set some other stuff, and there will be more properties on rule expression. Or not on rule expression, but on rule. Test value T and known value. There. Actually, baseline. I'm going to use the word baseline. There we go. I'm going to save all of this stuff. All right. And that gave us a bit more flexibility in terms of what we want to do here. Test value may be null. T must not be null. T must baseline value must never be null. Well, unless we're checking for null. So That could be silly. Yeah, I'm overthinking things. It's time for me to stop this episode. I'll be back around 1 o'clock. I'm going to try to make it as one on the dot as I possibly can. And that's Eastern time in the U.S., of course. Um, so until then, take care.